Okay, so 360 degrees on them. Oh, raise hand. Diane? Use pi, pi them all. Do you know the formula for circumference? No? Pi has to do with circles. Good. Yeah, Frank?
It has no angle and has radius.
Has radius or radii?
Yeah, and no angle.
Radii. Thank you. Radius. Nothing else? Erasing. Yeah. Lauren? Diameter.
Hello.
That's symmetrical. Okay. Yeah. Anything else? Yeah. Okay, well, we're not reading off of our notes. Okay. You know the area of a circle? You know the area of a circle? Do you raise hand? Yeah? That's pi is 2.14. Yeah? Yes? Pi radius squared, very good. Area equals pi r squared. Formula you probably know. Or at least now kind of remember. Oh yeah, it sounds familiar. Okay. So let's get into what we're going to be focusing on today. But all these things we will talk about. Okay, a circle is a set of points in a plane that are equal distance from a given point called the center. Okay, a circle is named by its center point. So all of the points on this are equal distance from this center point. And that's why rotations go in a circular motion, because they're all going to be equal distance from that center. Okay, we have a radius, which is a segment whose endpoints are at the center and a point on the circle. Okay, so this is what we call a radius. Goes from the center to a point on the circle. Then we have chord. A chord is a segment, that's kind of important, whose endpoints are on a circle. So this is what we call a chord. Diameter is a chord that contains the center of the circle. And then the length of the diameter is twice the length of the radius. So this is the diameter. Any questions? Okay, then we go on to a secant. Okay, secants are different from a chord because secant is a line that intersects the circle and 2 points. A chord is a segment, that means it doesn't go on forever, it stops. Secants are lines that go on forever. So this is a secant. Okay, a tangent line is a line in the plane of a circle that intersects the circle in exactly one point. So this is a tangent. Any questions over there? Okay, so the other one should have been right here on the other side. And it'll be x equals 8. Any questions over that? Okay. Now moving on. Okay, this is really important. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle. Oh my god. At its endpoint of the circle. Okay? Okay, in order to prove a line is tangent, you need to say that it's perpendicular to the radius at its tangent point. So you want to say, I'm going to label some of this. Let's call this circle A. This is B. We'll put C here. Okay. And we'll say line CB is tangent if and only if AB is perpendicular to line CB. Okay, so the other one they're saying is C tangent to circle B. In order to prove that, we need to prove that these are perpendicular. Is perpendicular to EC. Any questions over that? Okay, we're going to do that by proving triangle DEC is a right triangle using A squared plus B squared equals the hypotenuse squared. Any questions about that? Okay. So in this, can someone raise their hand and tell me what the hypotenuse is in that triangle? Yep. 40 what? Not 43. Has to be opposite. This should be the right angle. Yeah? 45, or segment BC, should be the hypotenuse, because it's opposite the right angle. Okay, so we're going to say 11 squared plus 43 squared has to equal 45 squared. Okay, so we have 121 plus 43 squared is 1,849. That equals 45 squared is 2,304. I'm going to add these two. These are equal. Oh, that's wrong, right?
Yeah.
I see the wrong numbers. I'm using the numbers from the next. 2,025. That's 45 squared. Okay, so we're going to add those together and I should get 1,970. So that equals 2,025. No, they're not equal. Okay? Remember, that's when we use our therefore, with a little dot. Therefore, EB is not perpendicular to EC. So EC is not tangent to circle D at so in your homework you're going to have to use the Pythagorean theorem quite a bit. Any questions on it? Okay. Okay, so in the next example, this time they're telling me S is a point of tangency. That means that the solutions are, or the perpendicular to this. So TS is perpendicular to SR. To find R, we're going to have to use the Pythagorean theorem again. The A squared plus B squared equals hypotenuse squared. And when we're identifying the hypotenuse here, it's a little different. The hypotenuse here includes the radius and 36. So the hypotenuse is R plus 36. Any questions with this? Get ready, Tom. Okay, so we're going to do A squared the R squared plus the 48 squared equals the R plus 36, the whole thing squared. Now remember, when we square a binomial, we have to write it out twice. So we're going to get R plus 48, but R squared plus, I'm going to square 48 right now, and get 2,304. And then I'm going to write this out twice. R plus 36 in parentheses times R plus 36. Okay, then I'm going to multiply it out. I'm going to do I have R times R is R squared. Then R times 36 is 36R. Then 36 times r is 36r. Then 36 times 36 is a big number. 12 minus 6. Okay, so now from there we have to combine our like terms. So we have the 36 and the 36 over here. We get r squared plus 2,304 equals r squared plus 36 and 36 is 72 r's, then plus 1,296. No, you don't add the r's when you're combining them. I have like PlayStation 1, another 72 PlayStation 2, PlayStation 1. Am I going to get PlayStation 2s all of a sudden? No. I'm just counting how many PlayStations there are. So we're just counting how many letter R's there are. There are 72 letter R's, not R squared. Make sense? Okay. Okay. So now we want to move the R squared to the same side. So I want to move this to this side. So I subtract the r squared minus the r squared. This makes life easy because r squared minus r squared is 0. And I just get left with 2,304. Here, same thing. The r squared minus the r squared is 0. So I just get left with the 72r plus 1,296. Now this is an easy equation to solve. It's a big number. I'm going to subtract the 1,296 from both sides. That gives me 1,008 equals 72r. Divide by 72. Divide by 72. And I'm going to get r equal 14. So my radius of that circle is 14. Any questions over that? We're all good? Okay. So the next theorem we need to talk about is this. Okay, there are two tangent segments from a common external point are congruent. So if EA and BA are tangent to circle C, then CA is congruent to BA. Segment BA. Any questions over that? So in the example it says that AB and BC are tangent to circle D. Okay, again that means that AB is congruent to BC, to segment C. So you have a little mark there. So to solve for x, you just set them equal to each other. You say that x squared minus 4 equals 21. Any questions over that? gonna add 4 to both sides. You're gonna get that x squared equals 25. Now I'm gonna square root. And I'm gonna get x equals, what's the square root of 25, class? 5 and negative 5. I don't know if the negative 5 times negative 5 got me that positive 25. Any questions over that? Okay, let's look at your homework for 10.1. For 10.1, you have numbers 1 through 8, all. And then 12 through 19. Any questions over that?